So we're trying to simplify this expression, this trig expression, down to it's a single trig function. So before we get to this, number one, I don't know if you've downloaded the this trig identity sheet. There's many out there, but if you just, I've got this linked in Canvas also. But if you can't find that link or just don't want to go look, in Google, just search for SOS trig, and this will take you. It's almost like the first link will take you out to this SOS math with a trig table. You can download a PDF copy of it. You get all the trig identities. There's many more, but the main ones. Aren't going to even look at them all in this class. You'll need some. You'll need some of the later ones. What I'm going to try to have you see in this class is what will get you to do Calc 1. Go on to Calc 2, then you'll need to use the others and some other trig replacements that you'll learn about. Let's keep it easy for pre-calc. Um, so I'm assuming that you got down the chapter 5 stuff about sine and cosine and how those are linked on the unit circle. So that's related to this. So hopefully you go back and take a look at that if you haven't. That's in section 3. Now for this problem, what we kind of got to keep in mind is that cosecant is the reciprocal here. Let me get a highlighter going on in here. We know the cosecant is reciprocal of the sine, and secant is reciprocal of the cosine, and then of course that and so forth. And then we're gonna make use of these Pythagorean identities too. And in particular, we're going to use this one for one method. We'll use this one for another method, and which is easier? I don't know. And we're going to be using the tangent is equal to sine over cosine, or maybe it's cotangent equals cosine over sine. Notice reciprocal functions have reciprocal um, fractions that they're equal to. And now, so before we get to the trig, let's make sure you know how to deal with fractions. Refresh some arithmetic kind of ideas. If I have 2/3 divided by 5/3, 5/3, Dan, not 5/5s, 5/3. But my ninth graders are telling me this year that they were told to keep, switch, flip. So we're going to keep the 2/3. We're going to switch the division to multiplication. We're going to flip the second fraction. And then they certainly, what they like to do is they like to say, oh, that's going to be 6 over 15. And then, oh, I can divide each of those by 3. And that's 2 over 5. Some of them I'm getting to see, oh, well, instead of doing all that work, let's just, for lack of a better word, cross cancel those 3's out of the way. It leaves me with 1. But then 2 times 1 is 2, and 1 times 5 is 5. And that way we don't have to do that intermediate step. Okay, I think that's the fraction work you need to remember, how to divide fractions. Um, okay, so let's go roll. Let's get some rolling with the trig identities here. So the easiest way, it's a little more advanced, but not a lot more advanced. I would really like to get it so I would love to get rid of this cosecant squared minus 1. So if you go look in those Pythagorean identities, I'm seeing this one right here, and of course I had written it here. And then if and that doesn't really help me because that says 1 plus cotangent squared equals cosecant squared. Now I want to get rid of the cosecant squared minus 1. Remember, you can't just cross those out. You're breaking the order of operations to do that. So don't do that. I thought all of a sudden it occurred to me I better say that. So, but what we can do is we can subtract the 1, bring that over the cosecant squared, and look at that. So that's just telling me that I can replace that whole mess with a cotangent squared. And then if you think about dividing fractions, it's the numerator divided by the denominator. And now if we want to get back to that keep, switch, flip thing, at this point it might be easier to rewrite these things in terms of sine and cosine. And usually that's my fallback method when I'm stuck with the trig identity and I need to do some uh, combinations with it. I'll rewrite everything in terms of sine and cosine. I'm going to show you another method where I use that and I don't use this trig identity. So if this is confusing, hang on a minute and maybe you can look at the second part. That'll make it more easy. So what I did is I know that the cosecant is the reciprocal of the sine, so the cosecant squared is the reciprocal of 1 over sine squared, and the cotangent is cosine over sine. But if they're squared, so I I just kept the squares along. Remember, if I have 2 over 3 squared, that's the same thing as 2 squared over 3 squared. So you can go backwards and do it that way too, or whichever way that gets you there, and that's what I used here. So then I've got this, and then now I'm going to do that keep switch flip thing. I'm going to keep that one. I'm going to change that to multiplication. I'm going to flip that, which gives me the sine squared over the cosine squared. And what's so nice about that is those signs cancel out. That leaves me 1 over cosine squared. And we know that the reciprocal of 1 over cosine, or 1 over cosine, is the same thing as secant, and secant squared. So we took that mess and made it be that. Okay? So let's look at it with just going straight to switching to sine and cosine. So here was the original problem, and I took and wrote cosecant squared is 1 over sine squared, and I took this cosecant squared and wrote it as 1 over sine squared minus 1. Now, it'd be really nice if this were one fraction, so I'm asking myself, what's the common denominator between 1 and sine squared? Well, I got to multiply this by sine squared t over sine squared t. That gives me this expression, and I'm able to add those two fractions together. And now I'm going to do that keep switch flip thing as long as I remember that a fraction is really means divide. So I kept the first fraction, I changed the division to multiplication, I flipped the bottom, the sine squareds canceled out. That leaves me 1 over 1 minus sine squared t. Now we do have to use that Pythagorean identity where it's the sine squared plus cosine squared equals 1, because I want to get rid of the 1 minus sine squared. So if I subtract both sides, sine squared from both sides, it means I have cosine squared t equals 1 minus sine squared t. So I can replace this with 1 over cosine squared, and then that becomes secant squared, which is the same answer I got doing it the other way. Okay. If you haven't watched Patrick JMT videos in the week overview, I linked to some videos. Those are worth your time. Hope this helps.